So, quite a big group here. I'm very happy that there are so many people interested in our talk. Our presentation today is with the title A PaaS Service for Kubernetes on the Edge at Bosch. My name is Stefanie Juncker. I'm the product owner for the service we are introducing to you today. And with me is Emmett Bradley, the architect of the service. So in this presentation, we first want to give you some insights into Bosch, so the company we are coming from, and also Bosch Digital, our unit. And then I would like to introduce to you the Bosch Private Cloud, which is kind of the umbrella for the service. And then we get to the actual service, which is called Decentral Container Service. And you will get some more insights into how we are using it, what are our customers, how does the architecture look like, what are the use cases, and so on. So let's start with some facts and figures about Bosch. I think generally Bosch is a well-known company, at least in Germany, but I think also in other countries around the world. But I think some people underestimate sometimes the size of Bosch. We're actually pretty big. So in 2023, we had a sales revenue of 91.6 billion euros. And we have currently almost 430,000 associates worldwide. And also here you can see 470 subsidiaries in more than 60 countries, so it's really a huge company. And looking a bit into the business sectors, so what is Bosch actually doing, with what are we earning all this money here? So there are 4 business sectors at Bosch. I think first one here on the left-hand side is where we are also well known for. So Bosch is a leading automotive supplier. And this is the mobility sector, which you can see here. And Bosch is having here a broad portfolio ranging over hardware, software, and electronic components. And just to name here a few examples are the injection technology, different kind of powertrain peripherals, also driver assistance systems, and vehicle safety systems. So, for example, ABS or ESP is also coming from Bosch, and then also infotainment systems. Next to being in the automotive sector, Bosch is also a pioneer in the area of connected industry. So this brings us to the industrial technology sector. Bosch is here a supplier for software systems and components for manufacturing and logistics solutions. Then the one you can see here down in the corner, energy and building technology. Bosch provides here customized solutions for energy efficiency, safety systems, and also building automation. So both for, let's say, companies, but also for private use cases. So when you think about smart home, Bosch is also here providing a lot of different integrated products. So from thermostats for the heating to the smoke detectors, some window sensors, and all this kind of stuff which you can connect. And then the 4th sector, the consumer goods. I think this is also, again, something where Bosch is well known for. And consumer goods can be, again, divided into 2 different areas. So one are the power tools. So power tools aimed at professionals. Maybe you know them, the so-called blue tools. And then there are the green tools, which are more for amateur crafters. You can find there screwdrivers, drills, saws, and then also garden tools. And the second area of the consumer goods is the Bosch Siemens Hausgeräte. So it provides household appliances. And I also want to mention it here explicitly, BSH, because I think Emmett will also name it later on once again, so that you know what we're talking about. And in this area, also Bosch is providing everything from bigger machines like dishwashers, stoves, ovens, and this kind of stuff, vacuum cleaners, coffee makers, toasters, so also the small machines. I guess you're also aware of this. Then besides these business sectors, there are of course also some corporate sectors. And one is let's say the corporate IT. We're called Bosch Digital, so that's where Emmett and me come from. And Bosch Digital supports and consults the whole Bosch group in implementing digital solutions. and just to support Bosch to digitalize its business. And within Bosch Digital, you can find consultants, software developers, UX engineers, solution managers, architects, whatever you can think of in the software area. And you can see also Bosch Digital is, of course, pretty big. We had in 2023 a service volume of 1.8 billion euros. We have around about 11,000 associates in more than 50 countries all around the world. And also here it's important to say, so this is just, not in the sense of just, but the Bosch Digital, so this pure, let's say, corporate IT. Of course, there are many, many more software developers out there at Bosch within these business sectors, which I was just introducing, because also, for example, if you develop some solutions for smart home, then you also need software developers and all different kind of functions around that. So let's jump a bit into the topic. As I mentioned, I would like to first introduce the Bosch Private Cloud, which is kind of an umbrella for our decentral container service. What is behind the Bosch Private Cloud? We always say the Bosch Private Cloud is kind of covering the best of both worlds. What is both worlds in our case? We have classical enterprise IT in place at Bosch. We also have public clouds available at Bosch. And with the Bosch Private Cloud, we are kind of sitting right in the middle of this. So we provide some advantages from the enterprise IT. So we are an on-premise cloud solution. This means that our data is stored in the Bosch global data centers. And with this, we bring built-in compliance and security, which makes it for any kind of service provider or application owner easier to quickly bring their applications to life, because they don't have to bother so much about, let's say, Bosch internal connections. And also, Bosch Private Cloud is here, one pillar in the whole strategy of gaining a bit independence from third parties, because if such a big company would rely for cloud solutions just on, for example, one public cloud provider, of course, this would be quite risky. So therefore, we have multiple public cloud providers, and we also have the Bosch Private Cloud as another cloud solution, which is not directly dependent then on the external market. And then for customers coming more from the enterprise IT towards the Bosch Private Cloud, so now talking a bit from the other side, of course, as it is a cloud solution, it brings all the cloud advantages with it, so the elasticity, the scalability, the high availability, and then also the APIs to foster automation and to serve automation demands. Let's look a bit into the portfolio. What is very important here? So first of all, it's just an extract, but also what is very important here to mention is that the portfolio we have with the Bosch Private Cloud, it cannot and must not compete with any portfolio you can see for public cloud providers, because it's not our aim to build up a second AWS or Azure or whatever. But we want to offer an on-premise cloud solution with which we can cover, let's say, most of the important use cases for our Bosch internal customers. And therefore, you can see here on the left-hand side, starting with the infrastructure services, we have an IaaS platform built up on OpenStack. And then we offer different runtimes, like Cloud Foundry or OpenShift, and then also Rancher. Obviously, that's why we're here today. Then we have also different data management services in place, like Redis, PostgreSQL, RabbitMQ, MariaDB, MongoDB. I think OracleDB is also there now. Then different logging and monitoring services, communication, access management, credentials management, HashiCorp Vault, and so on. And then also different development tools. I think this might be also interesting for you to look a bit closer into especially the container offering which we have, which is part of the Bosch Private Cloud. So one is, of course, the decentral container service, which is containers provided at the edge in remote locations, but more about this then later on. And then we have the central container service, and central means it's hosted really in the global data center. And it's provided in 2 flavors, the shared and the dedicated one. The shared container service provides shared Kubernetes clusters. So here the aim is to benefit from consolidation effects if several customers can share their clusters. And then on the other hand, the dedicated container service provides dedicated Kubernetes clusters. And this is for customers who have some, let's say, specific demands towards more fine-grained control over their containerized workloads, maybe huge resource utilization, any special configuration needs, or also the need for privileged containers. And then here on the right-hand side, you can see the Bosch Container Registry. That's an on-prem registry solution to store and manage container images. So basically, you could say it's our version of Docker Hub, and it's completely built up internally, and it's also disconnected from the internet, and provides also some mechanisms for scanning, for security, and so on. Then once more, back to the big, bit broader picture. So, okay, there it got a bit destroyed, but I hope you can still read it. So why do we run the decentralized container service under this Bosch private cloud umbrella? Why don't we have some just standalone services? It's basically because we benefit of this umbrella which we have there. So one thing is that we have a central onboarding in place. So a customer once gets a cloud project, which is then also related to the cost center and all that, which allows us then also to do central charging. So service providers don't have to take care about charging individually. And then also once a customer is onboarded, they can book service plans, they can cancel their service plans, change their service plans, and so on. In our marketplace, you can see it here on the left-hand side, and the marketplace is offered as a UI or also with a command line interface, also to allow for automation. So this is something which is, I would say, also a bit close to what public cloud providers have in their offering. And then besides that, we have a cloud product management team in place, and this team adds up more central features. So one is the reporting. So we provide reports about financial figures and some charging information to the service providers, which makes it easier to steer the product, because of course also within the Bosch our services need to be somehow financially independent. We need to have enough customers so that it's also worth it to have the service in place. Then there's also communication channels in place. You can see there our website, which is available Bosch internally to inform about the Bosch private cloud. There's also a community, for example, where we regularly post some updates about the different services. There are regular newsletters being sent out and so on. And there's also a training center in place. And in this training center, we publish vendor-based training. So, for example, we also publish there the link to the Rancher Academy. But we also create our own trainings. We have a Bosch internal video streaming platform, and there we already published more than 50 videos. We offer webinars for our customers and so on. So generally, I would say we also have here quite a professional setup to somehow offer the same what also public clouds to do to our customers. Then let's jump into the decentralized container service, and for this I would like to hand over to Emmett.
Okay, then. Thank you very much. Okay, so I'm going to focus right now on the decentralized container service, which is built on Rancher. A little bit about me. My name's Emmett Bradley. I've been working with Bosch for the last 4.5 years, and I'm the architect for the decentralized container service. Okay, so dive straight into it. I'll try to not stick too close to the slideware, but some of the slides are pretty self-explanatory. So there are some pieces missing. Our service, what we aim to deliver is a stable and secure container platform in Bosch and BSH remote locations. So what does that mean? That we deliver Kubernetes clusters on the edge in factory locations. Right now we are live in approximately 40 to 50 remote locations in Bosch, and we are looking to roll out to approximately 100 locations over the next 2 years. Who is our client? In here, this section should say who our client is. Our clients are exclusively Bosch internal teams, so internal development teams, anybody who wants to deploy an application close to a production line. So logistics applications, something that is directly connected to the production systems, anything like that. What is our deliverable? We deliver a project space. So Rancher offers the possibility, as you mostly probably know, to this exclusive element of a project space. This is what we deliver to our clients. We don't deliver clusters per se. This is how we maintain a high SLA, that we manage the clusters within the DCS team, and we deliver project spaces to them, and we leverage permission and privileged access, which I'll talk about a little bit later on. Moving on. Okay, a little bit of the timeline here. The timeline, I had to fit some points onto a slide, but I've been doing this now for 4.5 years. There's a lot more points in the history, but these are some of the highlights anyway. So in 2019, which is, I started in 2019, yeah, I did indeed. DCS was born in BSH. This is the consumer goods division that Steffi just mentioned, which is the dishwashers, ovens, that kind of stuff. And it was initially not born on Rancher, it was initially born on Docker Swarm. We weren't entirely happy with Docker Swarm. Docker Swarm was used more exclusively in those days in the global data center, and they decided to extend it out to the remote locations. But I don't know if those of you have any experience with Docker Swarm. It wasn't so good in those days with managing remote clusters. So in 2020, we started looking quite closely at Rancher, and Rancher at the time was, without question, best in class for managing remote clusters. So we moved quick. We moved 16 production locations over 6 weeks, from 0 to production in 6 weeks on 16 locations. I remember there was some long nights, long weekends, not a lot of sleep, but we did it. 16 locations up and running, producing in a really short space of time. 2021, Bosch started to, what are they doing? What are they doing over there in our little subsidiary? And they loved it. So we started setting up proof of concepts in Bosch and started integrating ourselves with the Bosch private cloud. Bosch being Bosch, it's a huge enterprise. You saw the numbers. We started to come up against security regulations on a totally different level. And we had to look at firewalling our clusters. Our clusters are always being air-gapped, so there's always been a layer of security, even in the early days of DCS. But in Bosch, it was a totally different animal. So we had to look at putting our clusters behind firewalls, looking very closely at the SDN, the software-defined network, what CNI we were using. I'll talk a little bit more about that in a few minutes, but this was a whole different thing. The architecture changed rapidly. We had to think differently. It took us the guts of 12 to 18 months to come up with a resilient architecture. And finally, in 2022, we went live as a service part of BPC, Bosch Private Cloud. Since then, the take-up has been absolutely massive. Like I said, we're planning rollout to 100 different Bosch locations. And in parallel, the BSH rollout has, so back here where we started in BSH, the BSH rollout has grown in parallel, and I think we're now on approximately 40 different clusters and somewhere between 20 and 30 different BSH locations. Moving forward, what's the next slide? Sure, I'll work it out. Okay, here we go, right. A little bit into how we build the clusters themselves. So what you're looking at here is a cluster. This is a cluster for us. So this is a cluster in a factory. So a little bit of the context of what's in a factory from an IT and from an infrastructure perspective. All of our locations, Bosch or BSH, have 2 server rooms on their location. So if one server room fails, the other server room takes up the load. The clusters that we build are spread across the 2 server rooms. The hardware is spread across the 2 server rooms. The WAN connections are spread across the 2 server rooms. So if the power goes in one, or if someone with a low loader drives across the cables and cuts one server room off completely, the other room can take the load and production won't stop. So what actually makes up the cluster? So on the bottom layer here, you can see, I can use a laser, can't I? It doesn't matter. On the bottom layer, you can see the hypervisor. These are our VMware hosts. We're using VMware right now. And we have our storage and our filers. These are almost exclusively NetApp filers. On them, we put our virtual machines that make up our cluster. Today, we're using Red Hat. And on them, in the case of RK1, we have right now a mixture of RK1 and RK2 clusters. In the case of RK1, we install the Docker runtime, and then obviously Rancher, Kubernetes, and so on. In the case of RK2, love it. Brings containerd out of the box. It's great. Don't have to install Docker separately. And then we integrate with the Rancher console. We custom build all of our clusters. We build everything. We've got quite a comprehensive infrastructure as code pipeline set up. I'll talk a little bit more about that later on. And some of the additional services that we build in. So for Bosch, we include Longhorn. So we keep the management of the storage offering within our own management within DCS. In the case of BSH, we actually connect directly to these filers here and use it. Maybe some of you are familiar with the NFS provisioner for connecting directly to the NFS shares, provision directly on the filers. Like I said, in the case of Bosch, we're using Longhorn. Another part of the DCS service is ingress control, the ingress controller that comes out of the Rancher configuration, so the default ingress control, Nginx controller. We provide a wildcard SSL certificate and domain. So if we have any clients who come to us and want to publish their application, they can do so using the ingress controller within the cluster. Finally, up on the top layer, authentication and authorization, we're integrated with Azure AD, the Bosch Azure AD. And on the top level, that's what you're all familiar with Rancher, the projects. We initially were doing multi-tenancy, so we had clients, parallel clients in the same clusters. We're stepping away from this, slowly stepping away from this as we get into topics around privilege and privilege control and ensuring that different clients can't negatively impact each other. I'll talk a little bit more about that in a moment. Moving on. Okay, same cluster, different view. Secure clusters, air gap critical. There's no internet on any one of our clusters. You cannot access the internet. Building Kubernetes clusters, cloud native this, cloud native that, building things that are so instinctively connected to the internet, natively connected to the internet without the internet, that was fun. And a learning curve. You have to think of the client here. You have to think of the company here. You have to think of Bosch. Bosch make stuff. Production is king. Production is the bread and butter of Bosch. It cannot stop. The most important thing is the thing on the right. It's the production line. They keep going. We have locations that are 24/7, 365, and they need to keep going. So the most important thing in the context of our clusters is that there's nothing, or reduce the risk as much as possible, that anything outside can impact this. So how do we do that? We do that with what you see. So here we have the Bosch network on the left, where there is internet access in there, but within the cluster itself, you've got a firewall that surrounds the cluster, essentially. And with the combination of the SDN in this case, we leverage Cisco ACI for our CNI, everything within is segmented. So if you're looking at this in the context of VLANs for the networking people among us, the node network, you see the VMs here, are in a network by themselves. That's in a VLAN. The system project, that's in a VLAN. Client project. They're all in separate VLANs, and they cannot talk to each other through firewall rules because they're all segmented on VLANs. We can then leverage the firewall to create firewall rules and policies, and that's exactly what we do. It's a complex process. That was that learning curve when we went over into Bosch. That harsh learning curve took a long time to really nail it down, but that is what we do today. And it really does work quite well. Moving forward. Okay, a couple of use cases. So yeah, here we have a dishwasher. I think it's a dishwasher. It is a dishwasher. A Siemens dishwasher. Yeah, there it is there. So maybe you have the fridges that can talk to you, tell you when you're eating too much. So all these IoT devices, you can connect on your phone, turn on your dishwasher, turn on your oven. I don't have them. I don't need that. But anyway. They're cool. They are quite cool. So we're talking about devices on the production line, and I've seen them. They pass the production line one every 30 seconds in some locations, depending on the location. What are our clusters doing in these factories? Our clusters, what lives on our clusters in these locations is the software that actually flashes these devices. So they pass across the production line. At one point, they get powered up for a moment. The system boards inside them get powered up. They connect to the Wi-Fi. They pull down an IP address, and then they get flashed their configuration. One of those every 30 seconds. Now, our platform lives the flashing process, the application that does the flashing. That's in that use case. Another use case that's out there, and this is across Bosch and BSH, are these little robots, and they're way bigger ones. There's huge robots, these automated robots that drive around the factory, bringing parts, bringing product from A to B, and the controllers for these live on our clusters. Yeah, that's kind of cool. Many, many other use cases out there, but I think they're the most visual ones. Okay, challenges and lessons learned. Okay, so client management and charging. So we started, and we were initially, for the first, you could say, 2 years with one major client, and then once Bosch picked us up, we started growing and growing fast, and then the number of clusters started growing and the number of resources. So the projects that we deliver to our clients, they're not just, here's a project space, go and deploy what you need. You have to remember, we're on-prem, resources are finite, so we request our clients to give us a picture on what it is exactly they require, so we define resource packs and build that in. So CPU requests and limits, same for memory as well. So this got challenging to manage manually. It was to extract a charging report to charge the clients internally. So we built up a single source of truth database, and what this is doing is it's reaching out and scraping the data out of every single project that we have deployed for contact information. We have it all annotated and labeled on every project. They're exactly what resources they're consuming, their internal cost center, contact point, all of that. And that makes generating a charging sheet and also visualizing to our clients. We have it published to a Grafana, and they can access and see, this is what I'm using. Another topic was not so much a technological implementation, but privilege versus high SLA, so service level agreement. The most important thing for our clients is they're consuming a service out of similar to something like Azure or AWS, and they want to know that a production line goes offline in, say, Dillingen or something like that. They pick up the phone and someone's going to answer. And please, I need help. I've got 300 guys on a production line here and production has stopped. I need to know I'm going to get someone on the other end of the phone. This is probably the most important thing to our clients. At the same time, the client needs to deploy operators, CRDs, things that require cluster level privilege. In the initial few years, we were looking at developing a custom authentication or authorizations to allow them to do this. And this is, I don't know if anybody has ever looked into that, but that's a dark rabbit hole and is very subjective, depends on the use case. So we simply said we have to come up with a shared responsibility concept here, and we leverage this similar to in the way that you might use your corporate laptops, and you request privilege to install an application, you get privilege for a period of time, install your application, and then they revoke the privilege. We do the exact same. What happens if there's an incident? We're still there. We maintain our high SLA. That's it. The client has to tick the boxes. I accept the risk, etc., etc. They can request it. But when it goes into diving into root cause, so when we're diving into root cause of, say, any kind of outage or issue, that if we see it's an application issue, well, this is where shared responsibility comes in. And finally, delivery times. So it's still a pain point, if I'm honest. This hurts us. There's a lot of cross dependencies that we have. We don't have everything in-house, and I don't want to have everything in-house in the team because that's siloing ourselves. I would like to say that we're actually, within BD, or Bosch Digital, we're maybe something of a pioneer for tearing down silos, especially in enterprise IT, because we have to talk to, you saw in the previous slide, we have to talk to the hypervisor guys, the storage guys, the Linux guys as well to get our virtual machines. There's a lot of the networking guys as well. And we've had to really work across these teams to get them to all collaborate and talk together. I had one or two other things written down here for that topic. One moment. Yes, our infrastructure is code. Our infrastructure is code. I'm sure it's the same for many of you. It's a constantly evolving beast. We're now building everything around ORK-A2. Something like 30 to 40% of our clusters now are on ORK-A2. Our entire pipeline has been rebuilt exclusively for ORK-A2. We build everything now using Terraform, which is now not free, thank you. That is now OpenTofu. Ansible is in there. So Ansible to leverage the configuration of the virtual machines, the hardware itself, VMware. And we use OpenTofu to leverage Rancher itself. And everything is managed within Jenkins. And finally, we are looking closely at immutable images and elemental. This is looking quite shiny and nice for us, and really looking forward to having some chats with the Rancher guys, the SUSE guys responsible for that. So yeah, that's, I think, it is the end. Yes. Any questions? No. Oh, okay. Hang on. Oh, God. Yeah, I got it.
I know it sounds strange because I'm a solution architect from SUSE, but did you think about including also new vector in the segmentation part when you're speaking about your air gap cluster, just to be sure that you manage properly separation of the projects?
Yeah, good question. We did do a proof of concept with NeuVector. We were there before SUSE actually acquired NeuVector. And we liked it. We liked it a lot. We looked at it in parallel with Sysdig, which was also a really cool product as well. We used it. There's a super amount of potential in there. However, internal processes and the way Bosch works around enterprise IT, and we're kind of treading the line between enterprise IT and cloud native, that we must leverage traditional firewall techniques. And that's why we didn't necessarily, it's there, it's very much on our radar, and we are trying our best to convince and demonstrate the power of NeuVector to the IT governance department in Bosch. But we are also obliged to use kind of the more traditional approach of firewalls and with the combination of Cisco ACI. So that answers our question right now, but certainly want to look in a different direction with the likes of NeuVector.
Thanks. Thanks for the presentation. The life cycle of Kubernetes version is quite rapid. I think there are 3 versions per year. What's your strategy with regards to the upgrade of those versions?
Painful question. We try to take the least impact to our clients as possible. Try to not interrupt our clusters as much as possible. Again, focusing on Bosch, as little interruption as possible to production. We can't avoid it because the world moves so fast. Generally speaking, we try to aim for one major release, major or minor release, depending on what is available out there per quarter. But generally speaking, we try to stay as close to just about keeping us inside of our support contract with SUSE. If we have to update, we have to update. We are controlled by the ACI CNI, for example. If there's some bug fixes in there, but they need the new Kubernetes version, then we update. But generally speaking, we have an update schedule that allows us to update Kubernetes version, major release, at least if we need to, once a quarter. Oh, the question, sorry, yes, I need to repeat the question. The question is can we go through the 100 different locations in a quarter? We actually go through, so if we're doing a Kubernetes update, we have dev, QA, and production environments all separated. So 3 different Rancher instances, and today, 3 different Rancher instances, 1 for Bosch and 1 for BSH, so 6. And the way we do it is, so say for example for Kubernetes update, just to pick one, Kubernetes update from 26 to 27. We will do, in the first week of the month, on a Tuesday, we will do our dev clusters. And we'll do our dev clusters in Bosch, and we'll do our dev clusters in BSH, and we'll do all of them. And that could be 40 clusters. Then we'll wait a week, a cooling off period for a week. The following week, we'll do QA, and that'll be another roughly 40 clusters. And then another cooling off. So there's, until production gets hit, we get to really see, there's 2 weeks in there to see, is there a bug? Is there something in there that's going to negatively impact our clients? And then production gets the hit. So we automate it all as well. So it can be run out of hours. We like to be there. We always push our clients to be as Kubernetes native with their applications as they can possibly be. They're not. But we try to push them as much as possible. And if they are, then updates don't hurt. But yeah, in one day.
Is that also true for OS updates?
So you're talking about the Linux machines underneath. So we are obliged by the Bosch CERT, which is the, what's CERT? The Security and IT Governance Department, to actually patch, security patch our VMs once a month. And yep, that all happens in exactly the same process that the Kubernetes updates happen. And we built our automation to cycle through the nodes in the cluster. So if we have a 30-node cluster, how's that structured? 3 managers, 3 Longhorn nodes, and 24 worker nodes. It will do every single node one by one. Graceful drain, forced drain if necessary, if the graceful drain fails, and reboot the node, put it back into the cluster. Uncordon, put it back into the cluster, moves on to the next node. This can be a long process. It can take, depending on the size of the cluster, but automation takes care of it, and there's fault checking in there as well. Yeah.
Are you hosting safety critical applications?
Shall I say that again?
Safety critical applications? Mission critical application.
Yes. Yes. We've got applications directly connected to production. If we have an outage on a Saturday at 3 o'clock in the morning in Chuzhou in China, we know about it. And this is production stoppage, shift workers going home.
And how robust you make the architecture? Do you have several sites? So are you robust to disaster?
Disaster in terms of disaster recovery?
For your data warehouse, yes.
So in terms of the clusters that are on location, so the cluster, say for example, to take the Chuzhou location, the way that cluster is built, it is spread across 2 server rooms. So if one server room goes down, the other server room can continue. There might be a failover of whatever it takes for a virtual machine to come up on the other side. Actually, we only fail over one virtual machine, which would be the manager. So quorum and all of that, 3 manager nodes. We would fail over one, and that would be it. So maybe whatever amount of time it would take for that to come up could be a downtime of 10, 15 minutes. In terms of the site being offline, the site, if there's a disconnection on the WAN for that location and the connectivity back to Rancher itself is lost, this is the beauty of Rancher. The cluster can keep working. The application is there. We can't see it. We can't reach it from outside, but, and this is what we sell to our clients, keep everything on-prem in the factory. That's the whole idea behind it. That's why we are on-prem and on the factory. We can respond fast, and you are not externally dependent.
Thank you.
My question is a bit out of scope, but out of interest. Do you, as Bosch Digital, also offer HPC services to departments?
HPC.
What is
high
performance computing, yes. GPUs in the clusters.
For example.
Yeah. Okay. Are we offering this? Have we done this? Yes, we have. Have we done it in proof of concept? We did it for a client in Bosch client in Reutlingen, wasn't it Reutlingen? And well, yes, Bamberg as well. Yes. We connected these NVIDIA Tesla GPUs to the cluster, installed the GPU operator. Everything worked. It was a proof of concept. We don't have a production rollout of this yet, but we've done it. It works, and we just need a client to take it up and say, yeah, go for it. So we can do it.
So, forgot to repeat the question, but now I'm trying to. So whether it's an in-house solution or not, what we're using for, you're talking about the marketplace, or you're talking about what we're using now? So the marketplace of the Bosch Private Cloud, it's currently not yet integrated with Rancher. The marketplace itself is based on Cloud Foundry. So we are relying on something which is there on the external market, but of course it's customized to our needs. And for what we use currently for the decentralized container service, it's Jira, so solution from out of the market. Yeah. Yep. Okay, so the question was whether we aim to build up a pipeline based on our marketplace, which directly triggers then the cluster creation. Maybe at some point in the future, but first of all, so at the moment we don't deliver a cluster, we just deliver a project on the cluster. And let's say our part of the automation is, our part of the delivery is automated. at the moment, we, let's say, take also some manual decisions about where to place the projects because, some are in decentralized locations. There we have to check about resources, what is still available. Some are in our global data center, where to place what on which cluster. So there's still some, just this decision process, let's say. This is manual. Of course, the rest could be automated. Also here, of course, we could put some logic behind, but at the moment we're, let's say, a bit hesitant about that.
The pipeline is there. The pipeline to create a cluster is there. We trigger it right now. It's very difficult to hand this over to the client completely because finite resources in these locations, you've only got so many resources. So yeah, we need to, we're keeping that in-house currently, and this is actually, you could say, the blocker, you could say, for integrating ourselves into the marketplace. It is all technically feasible, we could do it, but we have to have this stop point that we can manage these, and it's mostly around resource decisions. Yeah.
I know the Bosch have the usage for the public cloud service, like the AKS or Azure related services. So, but the Bosch have the private cloud to integrate. So, can you provide the example to integrate the public cloud?
So you mean what are the use cases for public cloud or private cloud, or
public cloud?
So
like
what is it?
Like a management Kubernetes service
on public clouds, or
yeah.
So I know that one example is around the automated parking. So you know when you have the parking garages, so new technology coming up where cars are getting parked there. So I know that there is something running with public clouds. Also, I think all the Bosch e-bike stuff would be one
That's
use case
there.
there.
As well, for sure. Also, the a lot of the applications that are running on-prem in the locations in the factories, they see a lot of their initial development on public cloud before they come to us. So they would do their development there and then refine their development, you could say, on public cloud, and then take their application and bring it on-prem. So how do we do resource? Question is, how do we do resource management and manage noisy neighbor? Tell them to shut up. No, that's on the recording now, isn't it? Brilliant. Okay, in terms of resource management, so we have that single source of truth, which is kind of like a single pane of glass for us to take a look at a cluster and see what state is it in, how many resources are available. We've also got hard limits on how big we go with the clusters. We've seen issues around with the CNI and things like that, that we can only go so big until we reach a point that we need to deploy another cluster. We oblige the client to come to us with a resource definition. They need to know, I have an application I'm deploying or whatever I'm deploying, and it needs this amount of resources, like we would all do if we bought a game back in the day. Look at the back of the box. Can my PC handle this, yes or no? They need to give us the resources. They need to tell us what they require. So we can then use our single pane of glass to look at the clusters and see, okay, place that there, that will work there. So that's how we do that. Noisy. It's a manual process, yes, to a point. In terms of the deployment of the project space, the deliverable that gets to the client, that process, the creation is completely automated. However, the placing of it today is a manual process. Again, for the same reason that we need to be conscious of the resources. Any GPU specific workloads? I think that's similar to the question before. We're open to it. We've done it in a proof of concept. We're open to it. Yeah, we're waiting on clients to request. Okay.